Welcome, ladies and gentlemen. The session today, it's chemistry, and we want to talk about three concepts. The first one is we want to talk about limiting reagent, including excess reagent. Then we shall talk about concentration and dilution. So let's begin with limiting reagent. When we're talking about limiting reagent, know that we are talking about reactants. When you want to perform a chemical reaction, there are reactants that you put together. Two or more reactants, you put them together and then you expect a product. So now what you should know is that between the reactants that you may have, for example, when you have two reactants, one reactant might finish faster than the other. So the one that finishes fast, the one which is in short supply, it is the one which is called the limiting reagent. So it is a limiting factor. It limits the amount of product to be produced. Then the one that remains, the reactant that remains, is the one which is called the excess reagent. So remember, when you're talking about reagents, we only concentrate on the reactants only. So now, how do you answer questions on limiting reagent? First of all, what you should understand is that we express the amount of substance in moles. We don't use volume, we don't use mass, we don't use concentration. When you are given a question, it means you have to take it to moles. That's when you work it out. So look at the question that we have. Yeah? When you pay closely to the question, it's saying 19.5 grams of zinc and 9.4 grams of sulfur were heated, and then this is what they produced. So now, first thing first, check if the equation is balanced. So as you can see, the equation is balanced. So the first question here is asking which of the two is a limiting reactant. So answering this question is very simple. What you should only do is you are going to go on the equation and then you pick zinc. Zinc, what is the mass that you've been given? You were given 19.5. So now we are going to find the number of moles for zinc. You say mass over molar mass. So the mass that we've been given for zinc is 19.5. Then the molar mass is actually 65 there. 65 grams per mole. So now the number of moles for zinc is 0.3 moles. We are done with zinc. Then you come to sulfur. Sulfur, the mass that we've been given in a question, you check the question is 9.4. So you come back, 9.4 divided by the molar mass for sulfur is 32. So what we find is 0.29. So you compare the two. Which one is smaller? So we find that the smaller number of moles is 2.9. So this tells us that sulfur is a limiting reagent because it has less number of moles. The question is done there. The second question is how many moles of zinc remain unreacted? How much zinc never participated in a chemical reaction? So what you should know is that the amount of reactant for the two should be the same for a reaction to come to complete. So if the number of moles are not the same, then the amount of product will be affected. So if you want to find out how many of zinc remain, just subtract the number of moles, the two number of moles. What is going to remain is the amount of zinc that remained. Because we know that zinc, for the reaction to be completed well, the two number of moles should be the same. So the difference between them is what remained. So 0.3 moles minus 0.2 moles, it gives us this. So this was the amount of moles that remained for zinc. The C question is saying how many grams of zinc element remained? Simple. So since we have found the number of moles for zinc that remained, which is 0.01, so we can go to the formula. Number of moles is equal to mass over molar mass. Hope you remember this formula so well. Then meaning we are looking for mass, so it means the number of moles there is this one, then 65 there, cross multiply, so this was the mass. The question is done there. D is telling us that when you go to D, say calculate the mass of zinc sulfide formed. So please, what they want is a product. So wherever you are finding the product, you always get the mass for a limiting reagent. Always the mass for the limiting reagent is the one that you use to determine how much product is going to be formed. So how much mass do we have of the limiting reagent? Remember, the limiting reagent is sulfur. So you go back to equation and check what mass were we given for sulfur. It's 9.4 grams. So you are going to go back now. You write the ratio. The ratio is going to be between sulfur and zinc sulfide. So when you check the molar mass, actually the mister, it is going to be 32 for sulfur. Then here zinc 65 plus 32, you get 97. Then 9.4 we were given in equation X. Then what we find is 28.5 grams of zinc sulfur produced. So this is how we find the limiting reagent. Remember, if a question is given in moles, it's even easier because you definitely go to number of moles and then find which one has less number of moles. It's the one which is in short supply. So let's go to concentration. Concentration is simply put, I'm sure you've faced across in a life situation where you go buy Mazoe drink and then you say this drink is too concentrated, and what you do is you add something there. So when something is concentrated, it means it has a lot of solute than solvent. Remember that a solution has two things. A solution has a solvent, then it also has a solute. So a solute is a thing, any solid that dissolves in a solvent, like salt, sugar, is a solute. So when these combine, they form a solution. So now when you say concentration, you want to find out how much of this is in a solution. That is what we mean by concentration. So now concentration can be expressed into units. It can either be in grams per decimeter cubic or in mole per decimeter cubic. And this is the formula that we use now for concentration. And the formula is C equal to N over V. And so what we are trying to say there is that concentration is represented by C, number of moles, then volume. So sometimes here they can be mass. So now let's try to answer one question here. Yeah. So before we answer one question, there's something that I want to emphasize, that if concentration is expressed in mole per decimeter, it means that concentration is called the morality. So it means wherever you are finding morality, you need to have number of moles, and then the volume should be in decimeter cubic. That's what it means. So now, there's a question that we have here. A solution of glucose contains 0.5 grams of glucose in 0.075 decimeter cubic of solution. Calculate the concentration of glucose in grams per decimeter. This is direct. So what we're going to do, C is equal to M over V. C we don't have, M we have in equation, this one, V, that one. Then when you divide 0.45 divided by 0.075, you get this as grams per decimeter cubic. So that's the concentration. All right, we have another question. It's saying, what is the concentration of 0.5 grams of sodium hydroxide in 250 centimeter cubic of solution? So you have to write the answer in grams per decimeter and mole per decimeter. So we begin with grams per decimeter. So we are going to use C is equal to M over V. When you correct the data, C we don't have, M we have, it's in the question. Then the volume, it is in centimeter cubic. It means you divide by 1000, you convert it to decimeter cubic. That's the answer we get. So when you divide 0.5, this one, divided by 0.25, that one, you get 2 grams per decimeter cubic. The same is done. Now we come to concentration, number of moles over volume. So here you come for concentration, we don't have, but number of moles again we don't have. So it means we have to calculate M over molar mass. So 0.5, that is the mass we are given in the question, but the molar mass we go for sodium hydroxide. This is the formula for sodium hydroxide. 23 plus 16 oxygen plus 1 gives us 40 here. So the number of moles is 0.0125. So we get back to the question now. Where there is the number of moles, we place this. Where there is volume, we place this. And then we get 0.05 mole per decimeter cubic. All right. The last thing is dilution. Diluting something. The drink is concentrated. So you want to dilute, meaning you are adding a solvent. Now, for example, you have juice. So when you are adding a solvent there, you are reducing the concentration of something, isn't it? It becomes less concentrated. That sweet start going away. So now there's one thing that happens when you're diluting something. The water there increases, meaning you are increasing the volume, but the concentration reduces. So that's a key concept you have to know about dilution. So dilution increases volume of a substance but reduces its concentration. So now, when you're talking about dilution, we have two things. There's the first is the molarity or the concentration before you add and the volume before you add. But after you add, you expect that the concentration, which is expressed in molarity, this M you are seeing is the same as molarity. It means concentration. It reduces, but we expect the volume to do what? To increase. So this is the question that we have now. 0.25 decimeter of concentrated solution of sulfuric acid of concentration, this one, is diluted to give a solution of molarity 2. You've seen that it has reduced. So what is the new volume? So here we expect the volume to be higher because the concentration has reduced. So we use the formula M1 concentration, then V1, which is concentration or molarity, M2 V2. So M1 18, V2 this one, M2 is this one. We are looking for volume. So here 18 times 0.25, then 2 times V2, you get 2 V2, then this time this, you get 4.5, divide both sides by 2, so that is the new volume. So when you compare the volume at first, it was this 0.25 0.25, then now it has increased. So this is what happens under dilution. Thank you so much for watching, and we will talk, I think, about 3 concepts in the next lesson. We'll talk about how to find the percentage of a particular element in a compound, the percentage by mass. Then we shall look at how to find the empirical formula, molecular formula, and then the percentage yield. Then that will be the end of more concepts. Thank you so much.